So today we're going to be looking at the real number properties. The main properties that we're going to be focusing on are commutative, associative, and distributive. So I'm going to go ahead and begin with those. Now, the commutative property can only be used with addition and multiplication. It tells you that it's okay to switch the order of your numbers or variables. So here, if we switch A and B, you get the same thing as if you had B first before the A. So it's okay to switch the order when you're adding or multiplying. Associative property tells you that it's okay to group differently. Now, when I say group, I mean what's under or inside the parentheses. Now, just because you see parentheses doesn't mean it's associative. It depends what they're grouping within there. So if you look here they're grouping A and B, but here they're grouping B and C. The order of the addition did not change. So you still have A plus B plus C on either side. It's just here we're going to group A and B together first and add here B and C. And it's okay to do that with addition or multiplication. Distributive property you've seen a lot in algebra. That tells you that you multiply what's on the outside by everything on the inside. Of the parentheses. So whatever's on the outside of the parentheses, you multiply everything on the inside. So here they have A, and you would multiply it times B, giving you AB, and then times C, giving you AC. If they put it on the right, but it's still on the outside, it's the same thing. So here they're multiplying A times B, and then A times C. Let's go ahead and look at some problems using these three properties. So here we're going to name the properties that are shown. Here we have 5 times 4 times 13. On the right side, we also have 5 times 4 times 13. So they didn't switch the order. If you look, they're just switching what's grouped inside the parentheses. On the left, they're grouping 4 and 13. On the right, 5 and 4. Since they're changing the grouping, that's the associative property. On number 2, on the left, you have 2 times x plus 3. On the right, you have 2 times x plus 2 times 3. So what they did is they took the 2 and multiplied it times x. Then they multiplied it times 3. That's your distributive property. On the next example, we have 84 plus 16 plus 2 equals 84 plus 2 plus 16. You'll notice here they switch the order of the 16 and the 2. When they switch the order of the numbers or variables, that's your commutative property. So they move stuff around. Next, we're going to focus on the last two properties, which are identity and inverse. So let's start by looking at the identity property. The identity property just tells you what you would add or multiply to get itself. So if you had A and you were to add 0, you would still get A as your answer. If you had A and you were to multiply 1, you would still get A as your answer. So it's giving it itself, therefore it's called the identity property. The one we're going to focus on a little more here is called the inverse property. For addition, that is telling you what you would add to get 0. So if you have A, you would add negative A to get 0, and vice versa. If you have negative A, you would add positive A to get 0. So you're just adding the opposite of what you have to get 0. For multiplication, you would take the inverse because this time you want to get 1. So if I have A, I would take the reciprocal, 1 over A, and that would give me 1. Let's go ahead and look at some examples using these. So on these last examples here, we're going to be finding the additive and multiplicative inverses. I'm going to start with the additive inverse. So if you remember from the top here, the additive inverse, you're adding the opposite so you could get 0. So really all you're doing is you're taking the same number, but you're going to change to the opposite sign. In other words, if it's positive, it becomes negative, and vice versa. So the additive inverse of negative 5/8 would be positive 5/8. The additive inverse of 1.25 would be negative 1.25. So I'm just changing the sign. And the additive inverse of positive 2.5 would be negative 2.5. So for additive inverse, same number, you're just changing the sign. Let's go ahead now and focus on the multiplicative inverse. For the multiplicative inverse, you're multiplying by the reciprocal because you're trying to get 1. So when you multiply the reciprocal, if you remember from Algebra 1, that just means you're going to flip your fraction. So we look back at example number 4. The multiplicative inverse of negative 5/8 would be negative 8/5. So you just flip the fraction. Now notice I kept the sign the same. So for multiplicative inverse, you're not changing the sign. You're leaving it the same. You're just flipping it, taking the reciprocal. Next, we have 1.25. Here we need to do a little more work because 1.25 is not a fraction. So I'm going to change 1.25 to a fraction. 0.25 would be 1/4, so 1 1/4. We still can't flip it because it's a mixed number. We need to change it to an improper fraction. So I'm going to multiply 4 times 1, which is 4, then add 1. So that gives you 5/4. Now you can take the multiplicative inverse. If we flip 5/4, the reciprocal would be 4/5. Now we look at our last problem. We have 2.5. That's a mixed number. Let's change it to an improper fraction. 2 times 2 is 4, plus 1 is 5. So it's 5/2. Now I can find the multiplicative inverse. If I take the reciprocal of 5/2, I get 2/5.